This video is going to show the connection between the area model that the students are learning right now in class with the standard algorithm that is used in division. Now, the standard algorithm the students will learn in an older grade. However, right now, the focus of the area model is it really helps students build a deeper understanding of what they're doing when they divide. So I'm going to show you just exactly how this would look with this problem. And on one side, I'm going to show you how the area model works. And this is the one that we talk about in class. And the other one, I'm going to call it the traditional method. Now, it's not that the area model is better than the traditional method. The thing about algorithms, which is this traditional method that we know, is a lot of kids have a hard time with them, or the ones who struggle with them is because they don't know what it is that they're doing. They can't actually explain to you what it is that's happening. And by going through the area model, when it comes time to do the algorithm, they're going to understand it so much better. And it's not going to be memorizing steps. It's going to be in the long-term memory, and it's going to be something they always remember because it's just going to make sense. So I'm going to show you how we would do this with the area model. Now, the area model is called the area model because it's based off of area. We know for area we take the length times the width. Well, in division, we know the inside. We already know the area. 870 would be exactly how much. And we know one side. However, we don't know this side. And so what it is it focuses the kids on thinking, okay, how many sixes can fit into 870? I know how many I have in each group, but I don't know how many groups I have. So we have them split this up so that they're thinking about hundreds, tens, and ones. And the reason why is because when we do our standard algorithm, our traditional method, we're doing that same thing. We start with the hundreds. We move to the tens and the ones. So I'm going to show you over here. I'm going to do the hundreds first, and then I'll show you how it would look in the traditional model. So what I'm doing is I'm going to guess only by hundreds how many sixes can fit into 870. So I'm going to think 6 times 100, well, that would be 600. That's pretty close. What about 6 times 200? And you'll notice I'm only going by hundreds. When I'm in the hundreds column, that's all that I'm allowed to do. Well, that's 1200. That is too big. So this is the amount I'm using. I know I have 100 sixes, and that's 600. Well, now I need to figure out how much I have left over, how much I still need to figure out. I still need to figure out how many sixes can fit into 270, because I only figured out how many sixes could fit into 600. And my original problem is right up here. So I have 270 I'm going to scooch over. Now let's look at that in the traditional model. What we're doing is we're going to say, okay, well, how many, a lot of times say, well, how many sixes fit into 8? But what we want the kids to understand is this isn't just 8. This is 800. And the great thing about our number system is we don't always have to write down all of these other zeros. Because we have a base 10 system, it works so beautifully for us. So we're thinking, how many sixes can fit into 800? Well, I know. I can just think how many sixes fit into 8 because of a base 10. So how many sixes fit into 8? Well, one of them will. But remember, that's how much? That's 100, which is exactly what we came up with over here. So we know we actually have 600, and that leaves us with, we have 200 left. So we know what's going to be the most helpful is now to kind of bring this down so we can look at the tens place as well. So you can see over here, I don't have that 0 written down, and over here, I didn't write 600. I didn't write 100. However, you can see that I don't have to. So now I'm going to come back over here to the area model, and I'm going to go through the tens. So I must think how many sixes can fit into 270. And I already know it can't be. I can't go by 100s again because that would be 600. So I'm going to just go by tens. That's all I'm allowed to do. I'm going to do 6 times 10, and that's 60. I can tell I'm way far away, so I'm going to take a bigger leap. And let's do 6 times 30, and that's 180. Getting closer. 6 times 40 is 240. If I did 6 times 50, that would be 300, which is too big. This is the amount I'm working with. Well, how many sixes did I figure? Well, it'd be 40. 6 times 40 is 240. when I have 46s, 240 is the amount that I have, that's 30 left. Now back over here to the traditional model, what we just did is we're figuring out, well, how many 6s can fit into 270? It's really what I'm trying to figure out. If I can think how many 6s fit into 27, well, I know 4 is going to be the closest that I can get to, and that's 240. That means I have 3 10s left, 30. Bring down my ones place. Now I'm figuring out how many 6s can fit into 30. And that looks just the same over here in the area model. How many 6s fit into 30? Well, I just know it would be 5 of them. If a student didn't know, they could do 6 times 1, because we're in the ones place, 6 times 2, and keep going until they figured out that it would be 6 times 5 is 30. How many 6s? 5 of them. How much was it altogether? 30. We have 0 left. So over here, same thing. How many 6s fit into 30? 5 of them. That's 30 altogether. 0. Here's my answer. In the area model, in order to figure out our answer, we just have to combine these up here, which is very simple because it's all based on place value. So our final answer is 145. So I think the important thing is whenever we work with the traditional model, the thing that we're finding is a lot of reasons why students don't retain it is because they don't really understand what it is that they're doing. They're following a series of steps instead of really understanding exactly what's happening.